Hi, welcome to another episode of Rustacean Station. This episode is This Week in Rust 443. My name is Tim McNamara and I'm with co-hosts Sean Chen and Alan Weimar. How are you two today?
Bueno.
Good. Yeah, you're alive. It's a bad week to be a human this week, I think. There's just quite a lot in the news at the moment.
Seems like a normal week for me. It's for all the new stuff.
So in terms of the course of the show, we'll go through the quote of the week. This week's newsletter doesn't have any official updates. So we'll go for our top three. And then we've had, if there's enough time, we'll see if we can pull out any other parts of the newsletter that we kind of want to chat about. Okay. The quote of the week. It is worth remembering that there is an infinitely large set of programs, but a very small set of useful programs. A programming language is a form of ad hoc compression algorithm. It is intended to sort the set of useful programs to have shorter encodings than the undesirable ones. Programs with certain categories of error or security vulnerable should be harder or impossible to express. So this is a quote from David Chisnell on Lobsters, and I think the intent there is to kind of really express that Rust has kind of a nice space in the design, that in the sense that it's able to make it very difficult to do very bad things. However, I'm not sure I kind of agree in terms of the compression algorithm, but I suppose it's a useful analogy. Does that quote light any light bulbs for you two?
I mean, it sounds like the theme is pretty similar to last week's quote. Saying that Rust limits how bad things can get. Or they mentioned that in the last week's quote as well.
Yeah, we need some more diversity in our quotes.
Yeah, the Rust safety is the only thing that's quotable, apparently.
The other thing I think I'll shout out, I'll just kind of insert something in there that I didn't include in the agenda, is the crate of the week. Partially because it is useful in terms of looking back to the previous week, and also because it's quite useful. This week's crate is Cargo Supply Chain, a cargo subcommand to gather author, contributor, and publisher data on crates in your dependency graph. So if you are interested in reducing the chances of supply chain attacks, that's something to investigate. Okay, Alan, what is your first pick of the week?
I forgot. Where's my notes? Oh, maybe I must have closed the tab. Yeah, so my first pick, let me just double check. Yeah, so things getting rusty in kernel land, things are getting rusty in kernel land, something like that. This is about the updated kind of support happening in Linux. So they're starting to really include, so they've been talking for, I think, at least a year, maybe almost 2 years, I think, about this, where the Linux is talking about adding in support for Rust. I believe when I remember this a while back, the couple of reasons why: one is the safety aspect, and two is the trying to bring in new talent, right? So a lot of times if you're using Rust or kind of these newer technologies, people are more interested to work in your project. Because most of the guys who are working on the kernel are getting to the retirement age and probably want to start relaxing. So it's a kind of a good recruitment tool. But in any case, there's been Linux vulnerabilities, and the exciting part for me is that it kind of validates that somebody with very specific taste in languages like Linus is actually saying yes to this, which is interesting. And actually, he's pushing it forward. Sorry, go ahead.
I was going to say, I don't know. He's at least not no, I think is a better approximation of his statement. It's look,
yeah,
I
Mhm.
don't want to close the door on this. We don't want to be dogmatic about C. But I think what they are trying to do is like open the door or let Rust in non-critical components of the kernel, and it's specifically driver related. That's my understanding.
Yeah, that's what I was going to get to. Is that okay? Yeah, I haven't heard the exact things in a while, but when I did read up some stuff related to the story, Linus is basically saying, yes, this is good, but you're missing these kind of like paperwork, etc., in order, such as a license. But yeah, finally, I think the most important part is that he's open to the idea. For somebody who's very headstrong about his opinions, like it's already kind of a yes to me, to normal people. But yeah, okay, so it's not a no. In any case, I think it's really important for the people to know that this is not about letting stuff into the actual kernel itself in terms of what do you call that? Like you said, the core pieces. But on the outsides first is kind of like a trial stage at least. And yeah, like you said,
Right.
they're doing this with the drivers first.
You will not require a Rust compiler to build the kernel. And the other aspect of this whole project that's fascinating to me, one is picking up on that recruitment point, because there are a lot of people who say, we would choose Rust, but it's really hard to find Rust developers. Whereas this is kind of flipping on its head, saying it's very difficult to hire C programmers with kernel expertise. So 2 decades down the track, we want to be able to have a defensible position there. And the other thing is the attention that Google is putting into this project. Like, they're funding it. And that strikes me as interesting. I don't even know if there's a better word. There must be some massive thing that Google really needs in order to be pushing this hard on a crazy idea like injecting Rust into the Linux kernel.
Well, I think the main thing is that they're trying to harden up the system, right? And so when we talk about, like, we're not going to rewrite core pieces because those pieces already have a lot of battle testing to them, so it doesn't really make sense. But for new things like drivers, I mean, those will always be needed. And so if you can get some safety to it, that's already huge. And Android has already been looking at this for some time. They've already publicly stated that they have that. And in the article, they list that actually there's already some drivers written in Rust. So in any case, this is called to be added actually in 5.19, kernel 5.19, because as of right now, 5.18 RC6 has already been released. And so with support added in 5.19, they're expecting to have 5.20 to have the first Rust driver already put out there. So in any case, I mean, this is huge, I think. And another thing I want to point out too is that because of Linux, I think it's actually pushing the Rust community forward too, because he's saying, wait, you can't just throw exceptions or throw panics in the kernel. We need to have what's it called, infallible or fallible methods or something. I forgot what the term was. Basically, that we need to have ways that we can allocate memory, and if it fails, then we can't just panic. We have to be able to somehow handle that in a solid way, for what I remember. So yeah, this is what this article is talking about, kind of the latest stages. And so a guy named Miguel, I forgot his last name, is heading this up. And like you said, it is being funded by Google, which is pretty huge.
Nice. Thanks, Alan. I look forward to Linux 520. Sean, where do you want to start with the discussion today?
I'll start with the deep dive into the borrow checker. So this was a presentation given by Nell Shamrell Harrington, who was the person who was previously recording the audio version of This Week in Rust, and she is one of the lead editors of the newsletter. But she gave a very nice presentation on a deep dive into the borrow checker. And I think the title, even just saying like a deep dive into the borrow checker, was a little... I think it sold her presentation short a little bit. She did a very good job of first starting off with like a very high level overview of all the different phases of the compiler. And then got, drilled down pretty deep into what the mirror looks like. There's the higher intermediate representation. She talked a little bit about the medium internal representation. I keep forgetting what the M stands for.
Yeah, it's middle or medium, probably middle, possibly.
Probably middle, yeah. Even talks a little bit about, LLVM IR. So, that was just it was very helpful for me for sure. And then this was just a really, really great presentation, and I thought Nell did a really good job with it. So if you can spare, a half an hour, or you can play it back at maybe 1.5 times speed, I definitely recommend it if this is a topic that you're interested in.
Does everyone else watch videos on like 1.5 times the speed? I know.
I mean, it depends if I have the time to spare. Or, sometimes even with something like this, I'll just play the audio and go and walk my dog.
Nice.
So, yeah.
Well, hopefully there are people on their commute or walking their dogs or other pets.
To be fair, this particular presentation would benefit more from sitting down and paying attention to the slides. Definitely you lose something by just listening to the audio, because there are code examples and snippets and stuff that are diagrams and things like that. So I'm not sure I'd entirely recommend just listening to the audio, but I did that a bit to kind of get through the whole thing.
Yeah. Did you learn anything about borrow checking? Like, don't mean to put you on the spot, but just kind of bringing your recollection up. Was there anything that sort of stood out?
Definitely the thing that sticks out to me right now is actually like when Nell talked about like basic blocks in the intermediate representation. That is what sticks out to me more right now, off the top of my head. So this was more details regarding the different intermediate representations and what those look like, and kind of what their use cases are. Or maybe I should say like how code is transformed as it goes through those phases. And actually that, again, is what's sticking through my head right now, since you're putting me on the spot. Yeah.
It's kind of a fascinating topic, that like the way that Rust becomes an executable binary, and the fact that like Rust C actually passes along this massive blob of what LLVM IR, so into the LLVM compiler, and apparently just it's like excessive, and that's one of the reasons why we're really slow. Is that actually LLVM, which is kind of in some sense being used as a subcompiler, needs to be it needs to be able to. LLVM is being used in some sense as a subcompiler, and it needs to actually take all of this input that Rust C has produced and distill it down. And like there are so many rabbit holes to explore in the space of compiling. Yeah, to be honest, like for me at least, once I had like a high level overview of all the different phases and all the different parts, and like as you said, LLVM has to do its thing in there. It kind of made me think like, okay, actually maybe our compile times aren't that bad. And like once I have an idea of everything that is going on underneath the hood, like I'm like, oh, okay, this doesn't seem that bad. Yeah, well, especially with when you think about the borrow checker, it's saying for every single variable in your program, I am going to check every single statically check that every single access of that data is valid. Alan, I'm going to throw it back to you. I've got a 4-year-old who really wants to me to change something on. I saw something out in the other room, so I'm going to throw it back to you and come back with my one.
Sure. So the next thing I reviewed, actually, this is going to be quite quick. It's about this tool called PixelBox. And PixelBox is I don't know how you would say this. It's kind of like an image searching program that this guy wrote. It's pretty cool. So he goes pretty in depth, at least for me, it's really in depth about how it all works. And what else I like about it too is that he does talk about what didn't go well. So the first part was about what is his tool, which I thought was really funny that a lot of the times is that he uses it to find images that are what he wants to have. So when he's talking with somebody and he wants to throw a meme into the conversation, he actually uses this tool to find the right meme, because he says before in the past it took him some time to find the right meme because he's got so many of these pictures all over. And I find it very funny that he he developed this tool. I think it's mostly for that, because he did talk about something else similar, but I felt like, mostly for meme finding. But he does talk about, what he uses. Sorry, go ahead, Sean.
I was going to say, so I didn't read this post, but like, is this doing image searching via like computer vision or something, or like what's the technique that's being used under the hood here?
I'm trying to understand. So it says he built it with Rust eGUI, which of course is the UI in Rust. Tracked Onx, I guess, TRACT-ONNX, and PyTorch. So it sounds like really a mishmash of things. I think PyTorch is Torch with Python
that's
or
machine
something.
learning. That's
so
learning related.
Yeah, I know that, but when he talks about like how it all works, I really don't get it, because even he was having a hard time trying to explain it. I think, or maybe it's just me kind of reading it in a weird way. But anyways, but the point is this: it's an image searching tool for his personal needs, and he open sourced it, and he's releasing it for everybody to use. And like I said, he talked about what went well, which is one paragraph, but what didn't go well is about 5 or 6 paragraphs. So I applaud him for talking about this, because I think it's you learn so much more about what's the right thing to do when you hear about what not to do. And anyways, it's a fantastic article. I think if you guys are interested in kind of hobby project what people are doing with Rust, I think this is a great introduction. And also he does how do I say this? Yeah, in general, I think that's great. And I think the whole wrap up is good. So yeah, if you're interested to hear about people using Rust and for their own projects, what goes well, what goes not well, and something that's actually real world. Yes, finding memes is maybe not the most kind of business critical intensive part, but in general, it's interesting. So that's this article. Mm-hmm.
Hey, thanks, Helen, for filling in while I went and helped out and got my daughter a drink, which is useful. Okay, cool. So I think I'm going to pick up the ball. And I wanted to chat about making Rust ergonomic to use. The post that I have chosen to start with is Rust Ergonomics Default and From. So this is a post about how to sort of simplify working with Rust, especially if you just find it kind of cumbersome and you're sort of starting out. And it turns out that there are some really useful traits, default and from, that make the process of instantiating new structs or new data, new values, as well as converting between them, a lot easier than if you kind of had to do it by hand. And so the post starts off with saying, look, I started with, my programming career kind of started in Python, and it was really easy to kind of like chop and change between types. And in Bevy, there is this notion of a bundle, which is kind of it's a collection of other stuff that Bevy requires. And the example that the author gives is this type alias that expands out to like 7 or 8 fields, I think. And each of them, if you wanted to create it by scratch, you'd need to kind of create, you'd have multiple calls of new, and there'd be like visibility rules and so forth. And like there's a lot if you wanted to create it. And it turns out that Rust actually provides the ability for you to kind of define a value as its default setting. And therefore, you can simplify a lot of the creation calls. And so people who are familiar with Rust will be able to know that this is it's been around for a long time, but it's very helpful to know if you're sort of starting out. And the other one is converting. And so the author does something that I would probably not do. So they have two structs. One is a color with a red, blue, and green channel. And then there is a new type, which is a kind of a struct, which has been a wrapper around the original. And the idea is that there is a method, color rotate, which clearly, presumably just kind of like, it changes the fields. So the green field becomes the red channel, blue becomes green, red becomes blue. And it's defined on the color, the original type. And UI color, which is the new type, can't actually it isn't a color from Rust's point of view because there's no inheritance. And the way around this is notionally with the from trait. So you just convert one to the other. Another way to do it would be to have implementations that just went to the 0th item of your new type struct, but it's good to know that there are multiple ways to go. So those are tips for starting out with Rust. I've got some nods from my colleagues, so presumably this is kind of easy. Can either of you think of anything else that's useful for sort of beginners when they find it kind of confusing? Or is that hard to ask? It's probably a bit of a general question.
Yeah, it's a tough one to come up on the spot.
Yeah, and if I was to ask that of myself, I wouldn't really know where to go. The hard thing is the difference. One thing that I still find really confusing is the distinction between the into and the from trait. They're kind of like symmetric, but not quite. And it feels like they're redundant, but they're not quite.
I just remember to implement the from trait if I need conversions because you get into for free, and then so I'm just like, don't need to bother learning about that one. Even though
there's a good book that I started reading and I need to read again because it's been updated. It's a MEP from Manning called Rust Like a Pro, something like that. That one, there's a lot of really good tips in there, and he does talk about that specific tip about the from trait. So I think that's a pretty good book for kind of people who know some Rust, but want to know more about kind of what's the right thing to do, which kind of reminds me of Tim's article from a couple weeks back. Like what should beginners do and how can they get into the language? I think a book like that, which is what the community is lacking, is, okay, digest all this information and tell me what kind of things should I know as a beginner. Okay, I need to make sure that if I'm going to do conversions, I need the from. Why? Because of these reasons. Okay. And then you just have to remember that or kind of write that down on a checklist somewhere.
Sean, what was... sorry, thanks. Alan, Sean, what was your number 2?
Number 2, I'll talk about the article titled Our Experience Porting the YJIT Ruby Compiler to Rust. I'm debating in my head whether I want to try saying the author's name. You know what? I'm not gonna risk it. So the author's name, I will butcher it, so I'm not gonna bother. So this was an interesting article in part because I think the author has a little bit of an unconventional background in that she comes from a PhD in compiler design and is now heading up this team at Shopify that is working on porting a just-in-time Ruby compiler from C to Rust. And so, I think a lot of the feedback that she provided and, the stuff she wrote about the team's experience doing this comes from a little bit of a different starting point than I think maybe the quote unquote conventional person who starts off learning Rust. I shouldn't say conventional, but the people who, like, you get a lot of folks coming from Python and JavaScript, and those I think are, in my mind, the most common that's kind of the most common pathway into Rust for
what you're
a lot of
saying is
folks.
we're not all compiler engineers with PhDs in computer science. Is that right?
Yeah, sure, right. And so again, the author just comes from this very kind of special or specific domain, I should say, with a lot of experience in previous low-level systems languages. One thing that she wrote that I thought was a little bit interesting. So to quote, she said, "Many people would tell you that the biggest burden when programming in C is worrying about buffer overflows and accidentally dereferencing null pointers. However, I think that what can make C programming tedious on a day-to-day basis is that the C language doesn't provide many tools to manage complexity." She goes on to say, as part of the C code base, they had to implement their own dynamic array type, which, was also just not very ergonomic or awkward to manipulate through preprocessor macros and not having type checking and things like that. Stuff that, is pretty bread and butter when it comes to Rust.
Right. So you don't have like like proper. You don't have modules in C, and
so they know enums, so they know mashing, and none of the awesome ergonomic tools that we're also used to and know and love. Some other things that I found interesting. The author also mentioned the fact that they're porting a C code base. Certainly, I think she made the observation that is like not quite the best starting point for a Rust project, in the sense that they had to do a lot of FFI to pre-existing C code. And as a result, there's quite a bit of unsafe just to perform a C function call. And there was a little bit of lamentation in the post to be like, can the compiler be smart enough to just be like, okay, yes, I'm making a C function call here. Yes, it's going to be unsafe. Do we really have to annotate it every single time, right? Like, it just adds a lot of noise and verbosity. And I think verbosity was just a little bit of a theme with the author's feedback as far as Rust is concerned. She also mentioned having to cast to different integer types all the time, because apparently that's another thing that happens a lot when you are implementing a compiler. There's just a lot of integer casting. And that's a little bit of a paper cut when it comes to Rust. I would agree.
Especially from a C like a C background, because C has implicit casts, right?
Mm-hmm.
So it's just, you just don't have that syntactic noise.
Right.
Although you do have the bugs.
Right, exactly. So yes, we know that the explicitness of casting is there for a reason. That being said, I think sometimes it is still a little bit of a hard pill to swallow in some use cases. But at the end of the day, despite these particular paper cuts and rough edges that the author mentions from her team's experience doing this port, at the end of the day, it is certainly much more the resulting Rust code base is certainly much more maintainable and pleasant to work with. And now that the initial work of the port is complete, they're taking time to basically focus on making the code base more adhere more closely with Rust idioms and patterns and things like that. So in the end, it seems like it was a good experience, which I'm happy to see.
I think that's fascinating, actually, to hear some experience of this in such depth, because I recall a couple of years ago hearing a lot of discussion that, Rust is a great language because you can effectively replace the ship, or like as it's sailing, or replace the plane as it's flying, piece by piece with like Rust components, because Rust can expose the exact same API or ABI surface. But it sounds like that's in practice not as nice to do as we, the Rust community, kind of tried to say that it would be.
Yes, it's certainly possible, right? It just, right, you don't get, as it's not as ergonomic to do so, as again the author points out. If we'd started this project from scratch, then right off the bat we could have made use of correct idioms and things like that. But because of this kind of transition period, the transitory nature of the project, it kind of has to be introduced at a later point once all the functionality is working.
Cool. Okay. Alan, how many C code bases have you ported to Rust?
Absolutely zero. I just ported some Elixir code over, and yeah.
I am super curious about this, but I'm gonna keep ourselves on task. I actually, I want to hear about Erlang and Rust actually quite a lot, but I will ask you for your third highlight of the week.
Yeah, so it's a framework called Asteracea. I believe I actually just looked up the pronunciation while you guys were talking, because this word is totally foreign to me. I'm not a botanist. I believe this is a plant word. And anyways, so what's actually exciting too is that I think because of the ease of use of using Rust, there's more and more web developers coming over to Rust, especially with Rust integration, with WebAssembly. And this guy is a traditional web developer. It sounds like mostly front end, from my understanding. And he built another, which I don't think is a bad thing, another UI library, which will compile to WebAssembly, called Asteracea. Basically, his whole entire thing is that he wanted to take a break from JS, like he's got JS fatigue. And he wanted to write something that's actually less resource intensive as opposed to React.js, some of these other ones. And he goes very in depth into here. I tried my best to understand. It blew right past me about a lot of stuff in terms of how everything works. What is cool though is he managed to kind of have his own little DSL for creating things. And I think if I work with it, it probably will make a lot more sense to me. But in the end, when I start seeing HTML mixed with a programming language that's not really HTML based, I feel very strange. Like JSX took me some time to understand. This is similar, but I think it's good.
So just random side note, Asteracea are daisies and sunflowers. So these boring plants that are quite simple. The idea is that the author of this post wants to try and create kind of like a simple base that if you were to deploy it, you kind of get this innate simplicity, which I think is a nice metaphor, but also it's kind of convoluted because it's a family of crates related. Lignin, which is the molecule, or is it a molecule or bigger than a molecule that trees use to create wood? But hey, who knows? Yeah, I don't know about. In one sense, you want to say, oh yeah, DSLs or domain-specific languages are fantastic, but also every new language, especially embedding HTML inside a macro, or just kind of kills syntax highlighting. It kills type checking. Rust Analyzer doesn't know what to do with them. There are a lot of disadvantages in creating a DSL with inside a macro inside Rust.
Yeah, also I agree that it's not. I had this talk before with Carl Lurch, and even macros themselves. I just feel like, yes, they add some nice sugar to it. It makes things kind of easier, but at the same time, you don't really know what's going on, right? You have to actually expand the macro to see what's going on. And even that could be a little bit confusing depending upon how they wrote the stuff underneath. So I'm kind of mixed, right? In Elixir, we have quite a lot of macros actually, but there's actually two rules that are known about macros, which is one is don't write macros, and the second one is really don't write macros. I think that was something like the rules. So I'm already kind of anti-macro coming into Rust, but at the same time, I do recognize that macros do provide readability. And again, counterpoint, as I said before, sometimes the macro making things more, more unclear can make bugs show up because you don't know what's going on. You don't know what kind of things it's pulling in. And this kind of also reminds me of the build RS. There's also this kind of thing where you build your system and it could start pulling in stuff that you have no idea what's going on. That's also a little bit scary too. So
yeah, just this ability in your build scripts
implicitness, right?
Do anything that you want.
Implicitness is scary.
Yeah, I've had many discussions with developers over the years about about magic, and I feel like magic is okay if you understand the magic, but too much, or there's definitely a psychological barrier to entry whenever you introduce it. But yeah, so in this case, the macros are being used to define, presumably, the HTML snippets or like the templates inside Rust code. Is that right? So instead of having a template file, you have compile time templates as macros inside your Rust code.
Yeah, I would say looking at the code, it looks a lot like you do JSX with the functional based components in React. That's what it looks like to me at first glance. So yeah, I mean, again, it's an acquired taste, but if you're using Rust, I guess that's a nice trade-off. But then again, Rust and WebAssembly still has the problem of being very slow for DOM manipulations still, which is something to be worried about.
It will, I think, never be quick because you have an intentional isolation between, like, the WebAssembly module has no access to the DOM. It can only really the only thing that a WebAssembly module can do is kind of manipulate strings of numbers. And so there's a whole bunch of serialization that goes on if you want to interact between WebAssembly and JavaScript, or at least and the DOM. What you could do, things that would do really well inside a WebAssembly module would be like some kind of image processing, or where you have like a big compute intensive function that you're calling, and like that would sit as a WebAssembly module very well. That would run very quickly. But I don't think that you could use Rust as a replacement for JavaScript because it's intentionally not that. At least that's my understanding. I'll be interested to see how many flames we are going to create in the comments. That's partially a request to send us comments and feedback. We're very, very welcome of it. So there's a Twitter account. We can receive email as well at hello@rustaceanstation.org. But I will also move on to Sean's last highlight.
So I'll make this a couple of parts. So first off, I did not, there was one paper under the research section, a paper titled Ferrite, something about session types. And I'll just shout out that I was actually one of the folks working on that paper as a coworker of mine. So I'll just shout that out. I don't actually know too much about session types. I've read one paper on, like, a more foundational paper on session types. I tried reading his paper. It was too over my head, so apologies. But session types are pretty cool because they, I think if I try to explain this correctly, they basically allow you to encode protocols, or I should say communication across channels. Like, you can encode those as protocols in the Rust type system. So then at that point, what you basically have is you can at compile time check that the channels that you're using for message passing, what's actually getting sent over, adheres to a protocol that is encoded into the types, which is super cool. That's about all I know about them. So for fear of saying anything incorrectly, I'm going to stop that discussion there. So that was part one.
Are there any programming language designers in the audience? Please let us know what a session type is. I'm always confused by lingo in programming language like design. Affine types, sum types,
well,
product
as
types.
Far as I understand, affine types are just lifetimes, right? Like, that's like the academic term for them, I believe.
Yeah, that's right.
So, okay.
That you've got a type that actually has actually, I'm going to do a really bad job of explaining this, but the term comes, or it's related to affine transformations in computational geometry, right? So you have a vector in computational geometry, and you want to kind of apply some transformation in linear space, and that's what an affine transformation is. Whereas, actually, no, let's stay on track. Otherwise, there are just two or three people talking about something they know very little about, which is designing programming languages and jargon, and angering everyone.
I make no claims that I deeply understand the stuff that I'm talking about. I just find it cool. But anyways, what I actually wanted to talk about, what I actually wanted to highlight, is this new section that's being added to the newsletter, which is RFCs that need testing. Presumably the idea with this new section in the newsletter is RFCs that, want some more eyeballs, or, more folks hammering out, kinks with them. They'll list these here as calls for participation to go ahead and, use these features that I guess presumably are made available in Nightly. And then as provide feedback on the RFCs to see, what has been missed as far as, bugs and kinks are concerned. So I'll mention a few of the actual RFCs in this section that I thought were interesting. The first one is an RFC to basically enable a lot of deduplication when it comes to working with cargo workspaces. So I haven't run into this issue personally, but apparently when you do a lot of work with cargo workspaces, there's a lot of duplication of metadata in between the crates that exist within the workspace. So I think, for example, any dependencies that maybe multiple crates in a workspace require, apparently that all has to be duplicated in the cargo toml files of those crates within the single workspace, right? And it just makes more sense and is cleaner to just be able to specify that dependency at the workspace level instead of at the individual crate level. So that's kind of like you generalize that idea a bit more to not just dependencies, but I think also some other metadata, such as information about the package. So things like the author, the license, the repository, which apparently before also had to be duplicated in all the different crates in a workspace. Now you can just...
effectively the only thing that you could really provide was just the names of the subcrates within the workspace at the top, at the high level. So being able to define a dependency once, and especially if you have the version pinned, and making sure that that version is the same, is consistently applied through the entire workspace.
Yeah.
I mean, it's obviously just a nice to have, but it's a very nice to have, actually, because it's kind of annoying. I had a code base at work where we got at least 12 crates inside a workspace, and whenever one of our minor dependencies needed to be updated, it was always like a really annoyingly long commit. I felt like there should just be one line somewhere. So that'd be great if that could come through. So please test.
Yeah, you should go ahead and test this at your work, Tim.
Don't push it back on me.
The other RFC I'll mention is the addition of scoped threads into the Rust standard library. So Crossbeam has been a pretty mature crate. It's been around for a long time. It has an implementation of scoped threads, and I guess the standard library stewards finally decided that the implementation of scoped threads is mature enough that they could go ahead and include it into the Rust standard library now. So that's pretty cool. Scoped threads basically are threads that you can spawn, and they can borrow data from the parent thread. And once the scoped thread goes out of scope, then that data is returned, and presumably you could have another scoped thread borrow that data again, right? That's one concrete example use case. But so that one's pretty cool as well.
Wonderful. Thanks, Sean. I will just make one quick call out, which is that if you're interested in participating in these RFCs, there's a really useful guide called the Guide to Rust C Development. It's the Rust C Dev Guide, which kind of is very, very thorough, but you only need to read a couple of sections of it if you're just doing testing. And it will explain to you how to effectively create your own compiler that you can apply these patches to and tinker around. So I'll make sure that the dev guide is linked to in the show notes. Right, so I think if I am correct, I've got 2 to go. But you 2 have both finished. So I'm gonna. This has worked out quite well actually because mine are both related. So I might chop and change. So I have 2 posts to talk about. One of them is extending Postgres with Rust, and the other is extending SQLite with Rust. And like, how amazing is it that they were able to kind of come in together at the same time, especially as they are doing it in very different ways. So I'll first talk about this Postgres project. Now, Postgres is a very large, mature database, and it also has a very well-defined extension process, but it's really quite difficult to work with if you are dealing with the raw Rust. And actually, I should just shout out for an open source project that I've been at the periphery of called PGX. So the authors of this, actually, no, it's a video. Go and say, look, when you want to interface with raw Postgres, it was easier to do it in C. And I just want to just going to from the sideline say, no, you're wrong. We've done it and we've made it safe, and we have a safe wrapper around it. This thing called PGX, it exists. So they extended Postgres by swapping out the storage backend and effectively keeping Postgres and Rust very separate. And so Postgres has the notion of a memory context, which doesn't align very nicely with Rust's lifetimes. The Rust compiler obviously has no notion that of the memory allocation behavior that Postgres has implemented. But in Postgres land, when a transaction is created, there is an isolated kind of memory component that any objects allocated are kind of reserved in that memory context, and Rust or the native extension is allocated objects inside that context. And the authors were finding it really complicated to try to enable these bits of memory which are provided to you by Postgres and work with them in Rust in a very ergonomic way. So they just basically did they just basically said, okay, well, this is too hard. We're going to just swap out the backend, and now Rust and Postgres know nothing about each other. So that was an interesting video to watch. I just kind of wanted to scream and say, no. It's easier than you think. Now, the other one is SQLite. Oh, actually, I should pause for questions. Do either of you have any questions or comments relating to databases and Rust?
I was trying to listen to this PGX thing. Is this the one for Go in Postgres? Is this what you're talking about for PGX?
No, PGX is now hosted under the TC. Sorry.
Because I did PGX Postgres, and the first thing that comes up is PGX, which is Postgres driver and toolkit for Go.
Oh, gosh.
Do you have the right name, or am I spelling something wrong?
It's definitely called PGX, and it's if you search for PGX Rust, you'll get it. It's under a GitHub account called TCDI, which is an American company.
Yeah, I see it now. Okay, it's interesting that they have the same name for the same domain.
That said, clearly we just need to fight about trademarks or something. I will, so PGX is quite good, but also I don't want to derail the discussion around this new backend, this thing called Neon, which is in essence, it's an attempt to create like a serverless platform in Postgres. So the idea is that if Postgres in the cloud doesn't need to worry about its storage backend, the actual database and the kind of the can be spun up and shut down very quickly. And it's very fascinating how they've gone about providing a Postgres facade to their own custom backend. That's effectively what they've done, is kind of get Postgres to do all the difficult things around query planning and optimization, but actually just not allow it access to any of its own indices, for example. Now, the other post was around SQLite. SQLite, the SQLite post is the opposite. So it is, how do I write an extension in Rust that is embedded inside the process? And in this way, and actually, it goes through in detail about adding regular expression support with the Rust regex crate, or regex, depending on how you want to emphasize the X, and it exposes it to Python. So I found this really fun and interesting and cool. And I mean, I'm a seasoned Rust developer now, and so a lot of I don't want to make a statement that it's very accessible, but to me, it seemed like this is a person who has spoken from experience. They've developed their own extension for the Z standard, which is a compression algorithm for SQLite, and they have gone and tried to write something that is fairly readable, and you can kind of do it yourself in something that's understandable. So I thought it was a well-written post, and I'm hoping that people will be able to play with databases in the future. Because from my point of view, I'm gonna cause some anger, hopefully. I feel like stored procedures are not as terrible of an idea as others do, because if we can get the compute very close to the data, then we don't have to worry about network serialization. And I just feel like if we can give our database superpowers, then the performance of our applications rapidly increases. Whenever I see database like rows being transferred over the network to an application to be post-processed and then kind of injected back into the database, or the results kind of being saved there, I feel like you're wasting milliseconds, and that causes me pain. Like, so
your time is very valuable. Every millisecond counts, right?
That's right. Like a little part of me dies when those electrons, they didn't need to go down that fiber optic.
I'll play devil's advocate here and ask, like, why did you lead that statement with being like, this is a controversial opinion?
So stored procedures are a nightmare to debug and a nightmare to So actually, no, I'll start again. So what is a stored procedure? A stored procedure in a database is historically it's been like some SQL or it might be some other function. Part of your application business logic gets sent to the database for processing. Now that means that things like version control become difficult. It means because part of your application is actually inside the database, which is not part of the rest of the core of the application. And so from a team management point of view, like knowing which version of the code is being run, all of these kinds of things become more difficult when you've got, in a sense, in multiple versions of your code running at the same time, possibly being a and historically there used to be this big division. I say like historically in the 90s or whatever, or even going on to today in some workplaces, where you've got a DBA, a database administrator, who is very protective of access to the database, and you might have like developers, and they might even be in different teams. And so there's this big petition between the data and the application. And so all of these organizational petitions actually cause friction if you need to update or upgrade something. And so for various reasons, stored procedures have kind of fallen out of favor. And I think that the way around this, just is to write native extensions. So you can actually provide functions written in Rust to your database to execute on your behalf. With cargo workspaces, ding, 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 chatting about this before, you're actually able to keep the code that will run inside the database, your Rust extension, alongside the rest of your application. And I think that that would mean that there are milliseconds to save, and if you've got tens of millions of requests, that's useful. Actually, more importantly than the milliseconds to save is the fact that you've got connections. Like, and like databases, you might only have enough. You might limit your number of concurrent connections to say 100 or something. And if you can have fewer, shorter-lived sessions with your database, that means that all of your clients are going to benefit, because it's much easier to serve the next client that comes on. You're much less likely to kind of create a vulnerable system. But that's just a thought.
Yeah,
Thanks.
I think most apps, they don't really have this kind of issue, but I can see how this is something. Yeah, I see your points.
Yeah, this is the argument, right? That you have this the majority of people, let's say 99%, or maybe generously 97% or something, don't have the problem of scale. Really, they've got different problems, and therefore you have like your Python app, and a lot of people, there's this mantra around, you don't have to worry about Rails, or you don't have to worry about your web app, because the database is always the slow part. Well, the reason why the database is always the slow part of your web app is because of these web requests. Because of these network requests to access the backend. That's the slow component. And therefore, if you can push a lot of work to the database, you actually reduce the number of interactions with the database, and therefore speed up your whole application. Now, it's hard to know if it justifies re-engineering your entire application. That's for individual teams to decide.
Yeah, I also agree with what you said about that part, right? Like, I helped one of my employees with optimizing some of his code. And so one of the things, he had to sum a bunch of numbers, and he was just grabbing a bunch of rows in the database and then summing it up in the code. I was like, you could just do this within Postgres. And in like half the time or something, it was like crazy. Yeah, so I think if you do need to make a request to the database, your best bet is to pass as much logic as you can to help with this problem, because like you said, yeah, network is really the biggest bottleneck in this kind of stuff. It's like that, what is it called, that comparison about, okay, getting something from memory is like walking over to the file cabinet and pulling out the data. Getting something from database is like taking a jet around the world and coming back with the data with a piece of paper, right? So make the best use of that. If you're going to fly the jet, make that trip really worth it, in my opinion.
Now, I am just going to give a moment to you two to think, is there anything that you wanted to shout out, or kind of was your honorable mention for the week? I'll give you a couple of seconds before, and no is a perfectly valid reason. One of the things that I wanted to say is that we had a very small performance gain in the Rust compiler. So yay, Rust C developers. One RFC was approved this week called Add Target Configuration. And so that is useful to know that we're making forward progress. And there are a few other PRs that are entering their final comment period. Alan, is there anything that you wanted to pick out or from the newsletter that you haven't already discussed?
Not from the newsletter, but I still wish somebody could explain this. What is it, Yi or Yeek or whatever we talked about a few weeks ago? Was it called
Yeet.
Yak? Yeet, yeah. I wish somebody could explain this word to me. It just started popping up in my life for the last 6 months.
Clearly, you're not the target market for this kind of like this part of internet subculture that you're missing out on.
I'm an old fogey, I guess.
Sean, what about yourself? Do you have any honorable mentions for you?
I mean, if I'd known you would have given me this opportunity, I would have saved the ferrite paper that I mentioned earlier. I would have mentioned it here, but I didn't know you were going to do that. So nothing on top of that.
Oh, sorry for that. And what an awkward part to end the meeting. But no, in saying that, it's been a fabulous week. I've enjoyed chatting to you both for the last hour or so. And I'll see you next week. Hope everyone is having great time with Rust. Cheers. Bye-bye.